Today's lesson is on reading circle graphs, so this will cover pages 69 and 70 in your Jump Math book. Now, before we begin, I just want you to think about what's the best format for you to use these videos. So for some of you, you might want to watch the entire video all the way through and then go and do your work. It is also totally fine if you find that you want to just go through the first question and then pause the video and go to your book and do all of question 1. And then you could watch the part of the video for question 2 and go back. So just see whatever format works for you, but I just thought I'd offer that possibility as a potential suggestion. Happy learning! The first type of question you're going to encounter for question 1 is asking you to calculate the percent. So they're giving you 2 degrees and they want you to figure out what percent of the circle is this angle. In order to do this, we need to start by writing our angles as a fraction. So 72 would be the part of the circle that we have. That would be the angle that we're dealing with. And the angles in an entire circle, so the whole of our fraction, would be 360. Now, there's no whole number that can take us right from 360 to 100. So our first step is actually to put this in lowest terms. Now, what we need to do to put it into lowest terms, there's 2 ways. The first way is we could find our greatest common factor for 72 and 360. And so you might be able to tell with your calculator, or you might just know that you can actually divide both 72 and 360 by 72, which would give you 1 out of 5. However, if you don't know this, it's okay to do things in steps. So you could start with 72 out of 360 and go, okay, well, they're both even numbers, and that means I can divide them by 2. So if I divide both the top and bottom by 2, 72 divided by 2 is 36, and 360 divided by 2 is 180. Now, I could look at this. It's divisible by 2. I could put them in half again. I also kind of see that I could divide it by 6, because 36 divided by 6 is 6, and 18 divided by 6 is 3, but remember it's 180, so instead of it just being 3, it would be 30, because we need to tag that 0 on the end. And then I could go, okay, well, you know what? I could actually divide this by 6 again, and that would give me 1 out of 5. It takes a little bit longer, but it gets you to the same place, so it's okay if you need to break those steps down more. Our third step is going to be to take our fraction, 1 over 5, and turn it into an equivalent fraction over 100. Because remember, 100 is a decimal fraction. It's quite easy to turn into a percent because percents are out of 100. So if I have 1 out of 5, to get from 5 to 100, I need to multiply it by 20. So that gives me 20 out of 100. So my final step is to turn the fraction into a percent. So I know that 20 out of 100 is the same as 20%. So that is what I will fill in on the blank in my question. I'm just going to do one more example for this question so that I can show you one more way to find the greatest common factor instead of doing all of our little division, so that you have multiple strategies. So if we were to make our fraction, we'd have our 45 out of 360. Now, in order to find the greatest common factor, we could also start just by finding all the factors of each number. So if we started with 45, okay, so 45 is 1 times 45. It's not divisible by 2 because it's not an even number. We can divide it by 3. Remember our trick, 4 plus 5 is 9, so that means the whole number could be divided by 3. So 3 times 15. I can't divide it by 4 because my closest multiple is 44. I can divide it by 5 because it ends in a 5 or a 0. So 5 times 9. I can't divide it by 6 because it's not divisible by 2, and divisibility by 6 is times 2 and 3. I can't divide it by 7. My closest multiple of 7 is 49. And I can't divide it by 8. Because that would be 40 and then 48 it would skip over. So these are my multiples of 45. For 360, I'm going to do the same strategy. So I could go 1 times 360. It's an even number, so I can divide it by 2. So that will be 2 times 180. I can divide it by 3 because 3 plus 6 is 9, plus 0 is 9. So 3 times 120. I can divide it by 4 because 36 divided by 4 is 9. So 360 divided by 4 is 90. I can divide it by 5 because it ends in a 0 or a 5. From our last example, we know that 5 times 72 is 360. I can divide it by 6, which will give me 60. I don't think I can divide it by 7, but I can divide it by 8. So it's actually 8 times 45. I can also divide it by 9. I'm just going to continue my list over here. 9 times 40. I can divide it by 10, be 10 times 36. I don't think I can divide it by 11, but I can divide it by 12, and that should give me 30. And then I can not divide it by 13. I can't divide it by 14. I think I can divide it by 15 though. And that would give me 24. I think I can divide it by 16. Oh, nope, that would give me 22 and a half. 360 divided by 18 is 20. And I don't think I can divide it by 19. And then I get to 20, which I've already used. So these are all of my factors for 45 and 36. I then can look and go, okay, what are all the ones I have in common? So I've got a 1 in both lists, I have a 3 in both lists, I have a 5 in both lists, I have a 9 in both lists, I have a 15 in both lists, and I have a 45 in both lists. The largest number there is 45. So we can divide both of these by 45, and that will give us 1 out of 8, and then we can look at turning that into a percent. Now, you might have noticed for this one, the percent is going to give you a decimal because 100 divided by 8 is 12.5. So you would have to actually multiply it by not a whole number, which is why they didn't give this to you in your question, because you would end up with a decimal, but it would be 12.5%. For question number 2, they are going to give you a graph, kind of like the one that I have shown you here, that has one part that's shaded in. And so they're saying that the part that's shaded is part-time staff and the part that's not shaded is full-time staff. So they want you to use a protractor to find the angle of the part-time section and then find the percent of people that work part-time. So you would start by taking your protractor and lining it up. So remember that you are lining up the bottom with one side, and then you're seeing what angle the other side goes to. Now this one comes right through, basically halfway between 40 and 45. Remember, we're starting, if this is our starting point, we look at the 0 there, which is why we say 45 and not 135, because then we would be starting on this side, look at the 0 and trace it around. So that would be 45 degrees. Now that we have our angle, we can figure out what percent of a circle that is. So 45 is our part out of 360 is our whole, and this is actually the same thing we just did in the last example. So we know that we can divide these both by 45, and that will give us 1 out of 8, which will give us 12.5 out of 100. I know when we're dealing with fractions, we typically don't have a decimal in the top, but that might make it easier for you when you're looking at your percentages here. So that would be 12.5% of the people. So part B, I'm actually going to do in green just so you can see the difference. So this part was part A. Tells you that each company has 60 employees, and so they want to know how many employees in each company work part-time. So we need to figure out 12.5% of 60. So we remember from yesterday's lesson, we start by turning our percent into a fraction. Well, we already have a fraction here that we can borrow. So 1 out of 8 of becomes times 60. So 1 times 60 is 60. 8 times nothing, or it could be an invisible 1, right? Because 60 is 60 out of 1 out of 8, and the fraction bar is code for division. So 60 divided by 8, and 60 divided by 8 is 7.5. Now, I'm quite sure that your questions in your workbook will not give you 7.5 people because they're already working part-time. I don't know how you can have a half a person, but this is how it would work. So just check over your measurements carefully. I knew mine was 45, but we'll see what yours will come out to be. For question number 3, they talk to us about a graph that's talking about the percent of playing time that a hockey coach gives each forward line. And they ask you as your first step to give it a title. So come up with something that is fairly succinct. Could just be playing time, right? Could be hockey playing time if you want to be a little bit more specific. Remember to capitalize each main word. Part B asks you to finish the key. So they've shaded every part in a different way, and they want you to label which one is which based on the amount. And they tell you in the instructions that the first line receives more ice time than the second, and the second line receives more ice time than the third, and the third receives more ice time than the fourth. So that means that the first line receives the most and the fourth receives the least. So it should be easy for you to just look at those pieces and figure out the biggest one is the first line, the smallest one is the fourth line, and just go in order that way. Part C asks you to use a protractor to determine the angle of each section in the circle graph. So use your protractor. I'm not going to go over an example of this part for you because I've just done that, but line up your protractor. Make sure that you line up the base arm. So that's where you have the 0 degrees with one side. And then you use the second arm of the angle to figure out what the degree is and count from 0. Part D of this question asks you to use your answer in part C where you got your angle to determine the percent of ice time. So we're just changing our angles into a percent. So remember, we start with our fraction for the angle and then we make it into a fraction out of 100. So they've given you all of these steps before they give you a big question like this. Part E asks you, if the team plays a regular 60-minute game, how much time will the second line get? So you're changing their percent into a number out of 60. So remember, we start by changing our percent into a fraction of becomes multiplying, and then 60 stays the same. So you do your fraction times 60, and that number that you get at the end when you simplify it is your answer. Question F is asking you how much time Ron would get to play if he's on the third line, if he has one game and they play for 4 minutes of overtime. So he doesn't play for that whole 4 minutes, but now your game, instead of being 60 minutes long, is 60 plus 4 minutes long. So when you're calculating your percent for the third line, you're not figuring out your percent of 60, you're actually figuring out your percent of 64. So you would take your fraction and multiply it by 64. And remember, this is for the third line, and that'll tell you how many minutes he would have played for. This question is very much kind of a combination of all the different steps we've already learned and putting them all together. So it is a little bit more involved, but you have gone through all of these steps. Question 4 is actually giving you an example of some things I showed before where we've had decimal percentages. So they're going to get you to take a fraction, turn it into a decimal, and they'll get you to round to 3 places after the decimal, and then change that decimal into a percent. So for example, we could look at 30 out of 360. Okay, now if we were to simplify this, we could divide them both by 30. So 30 divided by 30 is 1. 36 divided by 30 is 12. So our first step, we have our fraction. Here's 1 over 12. We're going to change it into a decimal. So when you put it into your calculator, you should get 0.083, and that 3 is going to keep repeating forever and ever and ever and ever. Now, because we are rounding it to 3 decimal places, we just kind of look at, okay, here's 1, 2, 3. The next number that would come after this 3 would be another 3, and a 3 tells us to round down, so we keep it the same. So this will be 0.083. Then we're going to change this into a percent. So remember, when we go from a decimal to a percent, we multiply it by 100, right? Which is the same thing as moving our decimal over 2 places. So that should give us 8.3. Okay, so this would be 8.3%, and they asked us to round to 1 place, so it's fine that we have the 1 place after the decimal here. When you are filling in your work in your workbook, you will notice that there's these little squiggly equal signs. So we've seen these before, remember? They mean that it's about. They're not saying it's exactly equal to. Because we're rounding, it wouldn't be accurate to say that it is exactly that number, but it is about because we're rounding. So when we would put our answer in, we would have our 0.083, which is what we found below, and that would become about 8.3%. Question 5 is asking you to do something very similar, but they're not breaking down the steps for you. They literally just give you an angle, and they say turn your angle into a fraction, and then turn that fraction into a percent, and round it to 1 place. So we have our angle is 60. To write it as a fraction, a whole circle is 360. Now, to make it into a percent, we can take it into lowest terms. So we can divide them both by 60. So that gives us 1 out of 6. And then we can turn this into a decimal. So if you were to take your calculator or to do some long division, you could go 1 divided by 6 is 0.16, and then the 6 is repeating. So when you multiply this by 100 to get to your percent, we move this over 2 places, that would give us 16.6 repeating. So we'd still have infinite sixes coming after it, but they ask us to round it to 1 decimal place. So we want it to end where the 6 is. So the number that would come after the place that we're rounding to would be a 6, which tells us that the number we're rounding to has to go up because it is 5 or greater. So this would round to 16.7%, and that would be your answer for that one. Question 6 is our last question, but it has several parts because it is a word problem. So they're breaking it down. The first part asks you to use a protractor to find the angle in the circle for each type of food. So we have learned how to do this. Question B asks you to find the percent of 360 to 1 decimal place. So to do that, we'll need to start with our fraction. That will be out of 360, so whatever your angle is out of 360. And then we will need to put it in lowest terms. And then you can turn it into a percent. So you can either do that by going from a fraction to a percent if you can get it to be out of 100, or you can turn it into a decimal and then into a percent. And they're asking you to round your percent to 1 decimal place, so just to the 10th place. Once you have found the percentage, then you're going to actually put it into the chart as a percent. So I'm just making up a number here that could go to 1 decimal place. Like you could have 32.7%. So you'd round it to that 1 decimal place and put it in. I've written the number in red so you know that's not actually the answer. For part C, they're going to ask you to add each of the percents together, and you're checking to see if they equal 100% when you add them all up. If they don't, you will probably need to go back and measure again to try to fix your answers to see if you actually have the right angles and the right percentages. For part D, they're going to ask you to round your answers to the nearest percent, so to the nearest whole number, and then see if they still add up to 100. So I'm just going to show you an example of what could happen. I'm using red again because these are not the answers, and I'm just going to add 2 numbers. If I had let's go with 39.5, and I was going to add 60.5, they should add up to 100. I can double check that here by lining them up. Yep, my decimal lines up, so that equals 100. But if I rounded each of them, right, so the 5 would make this round up to 40, and the 5 would make this round up to 61, that would actually equal 101. Because when we're rounding, we're actually adding a half to each of these, which means the whole answer goes up. So you might find that when you round to the nearest whole number, it's no longer adding up to 100%. Part E asks you, if Lena eats 24 servings of food each day, how many servings of each type of food does she have each day? So you're going to take your percentages that you found and figure out what percent of 24 that is. So remember, just like with the other one, we're going to take our percent and we're going to turn it into a fraction and then multiply it by 24 to get our number of servings that she has each day for that one type of